This is question 1 from the CCEA A2 Pure paper. Now this is the reserve one from 2022, so let's take a wee look. State whether the following sequences converge, diverge or oscillate. Well, it's sort of hard to explain a little bit, but if you just start putting numbers in here, if you put 1 and 2 and 3 and 4 and 5 into this, you can kind of start to see what happens. And because it's n squared up here and times by 2, whereas here we're just it's just normal n adding 3, whenever you start putting in big numbers, that's really kind of starts to head off to infinity. So in this scenario here, this one is going to diverge. Cos n pi over 3, as you put in different values for n. Well, we all know how the graph of cos looks. The graph of cos looks like this, so it's going up and down and up and down and up and down. So in this scenario here, this one then is going to oscillate. And this one here, so we have 5n over 3n minus 1. Again, as you start putting in different values for this one, it's kind of hard to sort of check, but as you kind of search, let's substitute, for example, the number 1 in. So 5 over 2. If we substitute the number 2 in, it's going to be 10 to 6 minus 1 is going to be 5. So that's the number 2 then. So that's going for 2.5 then to 2. If we substitute in the number 3, we get 15 on the top, and then 9 take away 1 is going to be 8. So that's getting smaller again. Do you see that? So that's going to be less than 2 if we kind of put it in. So this one is going to converge. On then to part B, wherever it's gone. Yep. Find this here means you summate it, so it's from 1 to infinity of 3 2/5 all to the power of r. So this all looks a wee bit confusing, but effectively we're going to substitute in here the number 1, 2, 3, 4 and so on and see what we get. So if we substitute in the number 1, it's going to be 3 2/5. Then the next term, it's going to be 3 2/5 squared plus 3 2/5 cubed. And from that I can see now it's starting to act just like a GP. So the first term in the GP is obviously going to be our A. And our A then 3 times 2/5 is going to give me 6/5. And what you get to get from this term to the next term, well, I'm timesing by 2/5 every time. That's how I know then it's a GP. So that means my common ratio then is going to be 2/5. So it's saying because every time you get from one term to the next, you're timesing by 2/5. That's pretty much how a GP works. So that's what we have. We're trying to find the sum then to infinity. So my sum to infinity is going to be A over 1 minus r. And that's going to be 6 over 5 all over 1 minus 2/5. You can put it in your calculator or whatever way you want to do, but the sum to infinity in this case then is going to be 2. Part C, the first 3 terms of an arithmetic progression are x, 3x plus 1 and 3x squared, and we have to find in the value of x. So again, this looks a wee bit confusing for us, but let's think about an arithmetic progression. We know where that is. Let's pick a random one, for example 3, 7, 11, 15 if I've got it right. This is an arithmetic progression. The only reason I'm doing it is just as a wee example to show you. The gap each time is the same. That's what an arithmetic progression is. So the gap between 3 and 7 is 4. The gap between 7 and 11 is 4. The gap between 11 and 5 is 4. So that means the difference between this and this must be the same as the difference between this and this, because that's the first, second, third terms. The difference between this and this is 4. The difference in this and this is 4. So we have that. So what am I saying? I know that 3x plus 1 take away x, that's the difference in those two, must be equal to 3x squared take away 3x plus 1. Hopefully you see what I've done there, and we're just going to solve this. 3x plus 1 take away x obviously then gives me 2x plus 1. That then gives me 3x squared minus 3x minus 1. If I rearrange it, get everything to one side, we have a quadratic here. 3x squared minus 5x minus 2, put it equal to 0. And we factorize then that quadratic, whatever way you solve your quadratics. You just do that, so 3x plus 1 upon x minus 2. So my two options then for x is going to be minus a third, and x then is 2. If we look back up to the question, it says where x is greater than 0, so it can't be this one. So x equals 2 then is our answer to that. Find the sum of the first 10 terms of this arithmetic progression. Well, we then need to find the common difference, and then we can use our formula to work that out. So we know the common difference is going to be this, take away this, for example. So we can write our common difference is 3x plus 1 take away x. That gives us, we worked this out in the last page anyway, 2x plus 1. But now we know that x is 2, and so our common difference then in this case, 2 upon 2 plus 1, and that gives us 5. So our common difference then is 5. So we know A is 2 and D is 5, and we're asked for the sum of the first n terms, so that's going to be n equals 10, and we use our sum formula then. So S of n is a half of n upon 2a plus n minus 1 d. Sum 10 is equal to a half upon 10 2a, so it's 2 upon 2 plus 9 and 5, and if we do our calculations there and put that all into our calculator, it ends up giving us 245.